Thank you.
Okay, so let's start. I will now give a presentation titled Implementing Interactive Window Maps with MapLibre and IMDF. My name is Haruki Inoue. I'm living in Japan. I serve as a boarding member of OSJP. My main work is iOS application engineer, but I also work with GIS technologies through my hobbies and side projects. Sorry, I can't speak English well. please forgive my poor English. I will do my best to study English. In this presentation, I will first discuss the current state of flow maps. Then I will explain how indoor maps are actually implemented in major map applications. After that, I will introduce IMDF, which stands for Indoor Mapping Data Format. I will then show you how to implement interactive flow map using MapLibre with IMDF. Finally, I will share some future possibilities for indoor mapping applications. I will share this presentation slide later on PretTalks and speaker deck. Let's start by thinking about our daily living. I spend approximately 80% of our lives indoors, whether that's in shopping mall, airport, office, office buildings, or other commercial facilities. This first shows a typical multi-story shopping mall. As you can see, this space can be quite complex with multiple floors and many stores, making navigation challenging for visitors. When we are in the indoor space, we often face the common questions. Where is the store I'm looking for? Or how do I get from my current location to the store? What time does this store close? Currently, when we need to navigate in the space, we have a few approaches. Many shopping malls still distribute paper-based flow map at information counters or entrance. Some facilities provide digital maps on their official websites. But there are usually just static images without any interactive features. Take a look at this. Sorry. Where? Oh, really? Sorry. This is this is a paper flow map of a shopping center in Hiroshima called Minamoa. We take this paper flow map with us to search for shops and look up information. However, major mapping applications like Google Maps and Apple Maps have started to provide interactive window maps for selected commercial facilities. Here's an example from Apple Maps showing an indoor flow map. You can see individual stores switch between floors. So how do these map applications actually implement indoor mapping? So Google Maps, the implementation method is not publicly disclosed. But Apple Maps use a format called Indoor Mapping Data Format, or IMDF. IMDF stands for Indoor Mapping Data Format. It's a unified specifications for modeling indoor space. It was developed by Apple to provide detailed indoor information in Apple Maps. Particularly for large public spaces like airport, shopping mall, and train stations. Apple announced it for this format at WWDC 2019. Apple submitted the specification to the Open Geospatial Consortium, or OGC, and it was approved as an OGC community standard in 2021. Let me highlight some key features of IMDF. First, it uses GeoJSON format, which makes it very easy to work with standard GIS tools and map library. Second, it's specifically designed for navigation and provide information, which sets it apart from other formats like BIM. Third, the data is organized in a layer structure consisting of multiple data sets organized by different purposes. Let me explain the structure of IMDF data. IMDF consists of multiple data sets, each representing different aspects in the space. You don't need to define all of this dataset, while some are required, like manifest, address, and venue. Many are optional depending on your specific use case. Also, we can extend the IMDF as needed. For detailed specifications of each dataset, including required properties and relationships, please refer to the official IMDF specification document. Here's an example of unit feature in IMDF format. Each unit has a unique ID, polygon geometry, define its shape, and properties like category, name, and level ID. Notice it is standard GeoJSON structure with localization names and display points for place labels on the map. Now let's explain the layer structure of IMDF. IMDF data is organized in the hierarchy structure. This diagram shows how the different components relate to each other. At the top level, you have the venue. A venue contains one or more buildings. Each building has a footprint and contains multiple levels. Each level contains units and openings. Each unit contains amenity and occupants. This hierarchy structure makes it easy to organize and query indoor spatial data. Now let me show you practical implementation. The application includes three key features. First, it displays floor map with interactive elements like units, openings, amenities, and occupants. Second, you can switch between different floor levels using a level picker. And third, user can tap annotations to view detailed information about occupants and amenity. The implementation follows a five-process. First, we decode IMDF GeoJSON files in Swift model object. Second, we display units openings as MapLibre style layers on the map. Third, we display amenities and occupants as a MapLibre annotation on the map. Fourth, we implement a level picker UI component that allows users to switch between different floors. And fifth, we handle tap events on annotations to display detailed information sheets. Let me show you the details for each step. The first is decoding IMDF GeoJSON files into Swift model object. And this decode function is the entry point. It loads all the IMDF dataset from the archive directory. Then with hierarchy data structure that mirrors the IMDF layer structure. The helper function loads individual GeoJSON files and pass them into future collections using TAF.js. The model classes maintain the hierarchy relationships we saw in the IMDF structure diagram. Venue contains levels contains units and openings, units contain amenities and occupants. Notice that amenity conforms to MLN annotation, which allows it to be displayed as a MapLibre annotation. After that, we decode each feature type. For example, this is a decode occupants function. Occupants does not define a geometry, so an anchor point must be associated with it. Therefore, while converting the data we need for the anchor contained in that unit. When user switches floors, this function renders all features for the selected level. This function processes each unit on the level. First, it converts the IMDF polygon geometry into MapLibre polygon features. And then it created a style profile based on the unit's category, which determines the field color for different units category. Finally, it adds any amenities and occupants associated with that unit. Openings are displayed as a line feature on the map. We convert the opening geometry to MapLibre polyline feature and create a style provider for them. We use a map style provider protocol to encapsulate how different feature types are rendered. The base class handles the common pattern of creating a source from a shape and generating layers for that source. A unit size provider defines how units are rendered based on their category. Each category has a specific field color. For example, restrooms get one color, elevators get another. The provider creates both a field layer and a line layer for the borders. For amenities and occupants, we use a different approach than style layers. We add them directly the map view as annotations by calling annotations. This makes them interactive and allows users to tap on them for more information. Amenities are displayed as annotation rather than style layers. This allows them to be interactive. Users can tap on them to see more information. The map annotation provider protocols define how to create custom views for each amenity type. Custom annotation view creates a visual representation with a color circle and a text label. The circle's colors is determined by the amenity or occupants category. The label displays the name and its positioned above the circle. When selected, the label background changes to yellow to provide visual feedback. The label picker provides a simple UI for switching between floors. Each button represents a floor level with its ordinal value. When tapped, the button notify is delegate, which triggers the map to display that FOSS feature. Each button is sized consistently with white background and gray border. When FOSS is selected, that button's background changes to yellow to provide clear visual feedback. And when I use taps annotation, we first highlight its visual by changing its label background to yellow. Then we display an information sheet with details about that amenity or occupants. If another sheet is already open, we dismiss it first before showing the new one. We created an information sheet view controller and populate it with the annotations data. For amenity, we show just the name and category. For occupants, we also display their opening hours. And this is an information sheet view controller that defines the contents of the sheet. Opening hours from IMDF are stored as strings using the OpenStreetMap hour text format, which we decode into structured day-by-day information. For each day of the week, we create a label showing whether the location is open or closed and what the hours are. Here are their screenshots showing the future of the application. On the left, you can see the map display with units, openings, annotation, and amenities and occupants. Details on different floors. Renderers on different floors. In the middle, the information sheet appears when you tap on occupants or ability, showing details like the category and opening hour. On the right, you can see how the map operates when switching between different floor levels using the level picker. Demonstration application. Okay, here. This application displays a floor map. Annotation tab. Show sheet store information. On change floor map. Before we wrap up, let me mention future possibilities. IMDF allows you to integrate with other data sources to implement various extended features. By combine IoT device in the positioning data and routing data, you can build much more interactive future. Let me summarize what we have covered today. The IMDF specification is available at the OGC website at this URL. This sample code is available on GitHub at the repository. Note that the actual IMDF dataset is not included in the repository due to licensing considerations, but the implementation code is fully available. I will be using Apple's new experimental live translation feature application for a Q&A session. Please forgive me if I speak in Japanese. Thank you.
Arigatou gozaimasu.
Arigatou gozaimasu.
Do we have any questions? I can bring. Do you want me to take the phone to the people with questions?
Yes.
Yeah. Do we have any questions in the audience? Yes. Should I take that one?
Okay.
Oh, that's okay from there?
Yeah.
Sweet.
So for the level selector, I've seen a few implementations. One of them with the +1 -1 button, and then the version that you showed. Like, what do you think about those two options? Because I'm sort of conflicted for my own app, which one I should choose.
そうですね。2 option? 2 option? Where? Where is it?
How do you see this option is good or not?
Do you think that this option or the +1 option
Ah. Option どういう意味ですか？
今これプラスとマイナスっていうオプションがあるけど。
プラスとマイナスのオプションってあります？
Here to change the floor, now we are using the +1 or -1, and you can change the map of the floor. Throughout the map. But
Okay.
there is another option or another.
Anyhow, let's skip that question. That's bad.
Okay. I like this UI. Apple Maps provides this UI level picker. なので私もそれで実装しています。so I also implement it.
Test.
Plus minus UI.
I have a question about something you presented as a future piece of work, which is enabling navigation. Based on what you had shown with the IMDF format, I'm wondering how exactly that format will facilitate the ability to conduct indoor navigation. When I think of indoor navigation, I'm thinking of perhaps a network of nodes and edges, so you can perform some kind of pathfinding algorithms on that. But how does the format like this, make that possible?
Oh. 今の質問です。
Let me slowly translate. I don't speak in Japanese, but I have the same question. So in your specification, you don't have node edge.
Yes. Yes.
So how we include it to your
So IMDF data format not provide load data. We created load data and not node edge data.
But as long as I understand, I'm working for Indonet as well. So as long as I understand, IMDF provides node link network.
Yes.
And big file, so you can do that. But my question is a little bit something related to his question. So in a single floor, it's easy. But for vertical connection, using, for example, elevator or escalator or stairs.
Yes.
That is my question.
I believe so. Relation. IMDF provides relation data format. Relationship file. This relationship file. Relationship? Nothing. Relationship file provides a relationship data.
Excellent. Well, thank you so much for your talk today. That was super
thank you.
interesting. We appreciate your time.
Thank you.